Okay, this problem is about energy and momentum of photons, right? So I'm shooting a photon at a particle, and even though, we know photons are massless, they still have momentum, right? So yes, that's weird. Yes, physics is weird, right? So this photon that doesn't have any mass has momentum, and you're going to shoot it at this particle, and it's going to make the particle go up and behave like a projectile, right? So how can we do this? So first it's making a projectile, right? But let's think about it just in terms of its y motion, right? So I'm only looking at this thing going like this. So here's how it's going to go up, and it's going to get slow, and then stop at the top, right? So it's going to look like that. I'm only looking at the y motion of it. Okay, so what do we need to do? So the first thing we got to do before we can do anything, we need to find the energy of the photon, right? From the laser. Okay. And to get the photon energy, I can just say energy equals momentum times speed of light, right? And I also know that power is the rate of energy over time, right? Because this gives me like 1,000 megawatt laser. So I'm given the power, and I need to figure out the energy of the photon, right? So I can take the power, and I can use this equation to say energy is power times time, and that'll give me the energy of the photon, right? So that'll give me E. Yeah, so I didn't even need this, right? I can just use this to get power. Okay, so now I've got energy. So the next thing I got to do is the momentum of the photon, right? That's going to become the kinetic energy of the pellet. So this photon momentum is going to it's going to hit this, and it's going to become the kinetic energy of the pellet. So this is where I'm going to say E equals PC, right? My energy of my photon, that's ugly, equals P times C. So that means that I'm going to solve for momentum. P is equal to E divided by the speed of light. All right, so I can do my energy divided by the speed of light, and that'll give me the momentum of the photon. And then once I know the momentum, I know that kinetic energy equals P squared over 2m, right? That's the basic relationship between kinetic energy and momentum, right? So if I take this momentum and I plug it in here, I can solve for kinetic energy, right? So now I have kinetic energy, right? So here I got momentum. Now I've got kinetic energy. Okay, so now I'm done, right? Because now I'm just trying to figure out how high it went, right? So now 3, it just becomes a conservation of energy problem, right? So kinetic energy becomes gravitational potential, right? Easy peasy. So you can say the kinetic energy equals mg delta y, and you can solve for delta y, right? You can just divide over mg, and then you can solve for the height that it goes, right? And then just remember, you got to convert to micrometers, right? So whatever your answer is, 1 micrometer is 1 times 10 to the minus 6 meters. All right, so not too terrible. So we had to find the energy of the photon first. First, we had to get this energy. And then we had to take this energy and convert it to momentum. And then take the momentum of the photon and say, okay, how much kinetic energy will it give this particle? Once we got that, then we can say conservation of energy. Kinetic energy of this equals the potential energy at the top.